Hi there, it's Mo here. Today I'll be going over how to get started making a 2D game using the Duality game engine and the C# programming language. This has been by far my favorite engine in the last 6 months, and I'm using it to create a game to release on Steam, which I'll tell you more about at the end of the video. One thing to note that as of the time of recording, Duality is only available for Windows only. However, the team are working on a cross-platform solution, so apologies to all the Mac users. Downloading the engine is pretty straightforward. You go to www.duality2d.net. I'll put the link in the description. Click on Get the latest build. The file size is roughly, it is 1.5 megabytes. Click OK, save the file. I've already downloaded it here. You extract it. It's quick extraction. Then you click on dualityeditor.exe. Accept the MIT license. And it installs the packages to run the game engine. And now you're up and running. The user interface is pretty self-explanatory. You've got your main sort of scene editor where you can put objects in, game objects, etc. You've got a scene view where you can put game objects in. It contains a hierarchy of all the game objects in the scene. And you've got your project view. So these are the folders that contain your various sprites, assets, etc., prefabs, you name it. You can click on any object in your scene view, and the object inspector will show the different components of that object, such as the transform. For the camera, you've already obviously got a camera component, sound listener to sort of detect sounds, and a velocity tracker to see how fast the camera is moving. Now with the scene editor here, you can switch between scene editor. You have a game view, which is the actual game when it starts to play, and a rigid body editor, which is when you edit the collision shapes of your rigid bodies, which we'll touch upon later. However, if you can have two scene views, or like two views of these, one at the top, one at the bottom. Well, to do that, you go to View, Camera, and it produces another sort of thing here, a tab, which you can dock at the bottom. And that can be either your game view or rigid body editor. So personally, I like it this way, because if I have something here and I can just see how the game actually plays down here while doing my editing here, which you can do at them as well. So you can edit stuff here and it will load real time down here. Anytime you want to save a scene once you've edited it, you can press this button here. It'll automatically save it for you. I'll go over the components used in Duality. First of all, to delete an object from the scene, you right click and press the delete button, or you can press the delete button on your keyboard. To add an object to the scene, you press right click, new, then you go to whatever object they require, such as game object, and that puts a empty game object on the field. So it's just like a container with nothing, but you can add a component such as a transform. transform component essentially gives the game object a position in space. So position here is X, Y, and Z. You can move it up and down. One thing to note here is the Y component here. Everything in Duality get renders from sort of like top down, so that means if you want to move something down, the Y value has to increase. If you want to move something up, the Y value, the position, has to decrease. With the X component is as you'd expect. Going right, X value increases. Going left, Y value increases. And you've got scale, which increases the size of the object, and angle. If we add a sprite renderer to it, so once you put a sprite renderer on, it automatically by default gives you puts the Duality logo in as the default sprite renderer. The sprite renderer would give you a good idea of what the angle does as well. So if we type in 90 degrees here, it rotates it by 90, increase the scale by 2, and it becomes bigger. Thing that's very important is if you go to settings, application data, put the scene here, so that will be the scene that you start off with, otherwise it will just be a blank screen. Now if we run everything, Alt F5, or if you go up here and press run game, we should have a Duality logo here. That's fine. So you can probably see that the cursor becomes invisible once you go onto the screen. We can fix that easily. So if we go to default user data, system cursor visible, tick that box there. There's lots of other properties here. We've got anti-aliasing, whether you want to be high, medium, low, or off. Window mode, whether you want it full screen or a fixed window. Different options here. And you can also adjust the size of the window here. And if you want this size to be reflected here, you on the game view here, we go and click this button and click on target size, and it just automatically does that for you. So now I'll show you how you can sort of input external assets into Duality, and how you can work with simple animations. So I've got a sprite sheet here from a game that I'll be making, just an idle animation. You literally drag and drop and put it just there. I usually organize my assets in folders, so if I right click, create a new folder, it's called this sprites and animations. You can drag and drop that into there. And you can edit this by clicking on it, and if you go right click, slice pixmap. So on this sprite sheet, all the sort of images here are equally spaced horizontally and vertically. So in order to play the animation, we need to slice this up into its individual sprites. So if we go to grid slice, if you count the number of rows, that would be 20. Columns would be 3. And once you're done, you press this button here. So just to repeat that again, I went to grid slice, then I put in the rows and columns, and it automatically sort of sliced the image up for me. Now if we go back to our scene, we can drag and drop this here, and automatically gave us a few components, a sprite renderer to render the sprite. The material here is using is the same one as here. So the texture and the material gets sort of auto-created once you drag and drop this onto here, if it wasn't already there. So if you press the play button, you can see the very slight animation that's playing here as well as here. We can speed it up by altering the anim duration here. So if we go to make it 1, it's much faster. So all those sliced images here gets played, all of them gets played in 1 second. So that's what's happening here. You've got different animation options here. You can have loop, ping pong, just a single frame to be rendered out of the animation, and you can also have custom animations as well, which is key here. If we stop that, so another way that you can slice images, I'll just put this here, there. Go to slice pixmap. So what you can do is, if say for example you don't have them equally spaced out like this, you can manually do it by clicking this button here and just drawing your squares. So that's 1. And that would be number 2, also 0 and 1 rather. And again, save it, Control S or File, Save All. Then if you drag and drop here, you can see that piece that we sliced off gets rendered. If you say for example you want the second one here, have that highlighted, and here you press the index of the sort of sliced sprite that you want. So if you press 1, it changes to the other part here. So that's the basics of the animations and sprite renderer. Let's delete that. Another thing that's essential for most games is physics and rigid bodies. So we can add a rigid body here. If we go to add component, rigid body, and it adds this rigid body here. If we go to here and go into rigid body editor, and you can see the rigid body on this red blob idle thing here. Go back to game view play, you can see it goes down. If we change it to the body type here, static to either static or kinematic, it won't move down. Alternatively, you can click on this ignore gravity here. And the most important ones here are sort of angular velocity. If you change this value, it starts to rotate, and the angular damping is like an air resistance when it rotates. The more it is, the quicker it starts to stabilize. Friction is pretty self-explanatory, ignore gravity, we touched upon that. If you put a linear velocity here, let's say that's the x value and that's the y value. If you put the x value as 1, it should start to move to the right. But if we increase the air resistance, which in other words is linear damping, to maybe bump it up to 111. Oops. Let's make it 5 actually. Yeah. It starts to move a little bit slowly. Along with this, you can edit the shape of the rigid body as well, or the collision shape. So by default, it would be circle. You can adjust the size of the circle or the radius rather of the circle by using this pointer here, or you can manually type in your preferred radius here. Other options is the position of the shape. So if you move it around, that alters their position. So you can assign it a user tag which would be involved in sort of code. So for example, if the player hits this, which has a user tag of 5, he takes damage. Restitution is essentially the bounciness of the actual collision object. You can mark it to be a sensor rather than actually involved in dynamic collisions. If you want it to be involved in dynamic collisions, you just turn this off. And that's friction and density. You can also delete the rigid body shape. Click on it and press the delete button on your keyboard, and you can redraw it. If you want it to be a square instead, you press this button or any polygon and you can make your square. And you can have more than one collision shape per game object, and you can sort of delete this if you don't want that. Highlight it and press delete, and then you can move this just here. Now to go into coding, you press this button here which says open source code. Before I press this button, it's important to note that it is highly recommended that you have Visual Studio installed prior to installing Duality. I'm using Visual Studio 2017, but I'd imagine anything 2017 or later would work. Now if you go to your custom component type here, so this shows you how to make a component for the game engine. If you come here and right click here and click on rebuild, so this component type should be accessible in the game engine now. Go here, click on anything here, go to add component. It's right down at the bottom, your custom component type. And we can add it on like that. It's important to know without this here, if it doesn't inherit from component, then it won't work. If we add a new script, let's name it example. Go to type in the namespace using Duality. Remember to make it public. You want to be able to use it as a component in the game engine, so we inherit from component. And there's a few more things that we can inherit from. One of it is ICMP updatable. So if you want this component to be active in the game loop, you use the ICM updatable here. If you right click on here or just hover over on top of it, click this, and if you go to implement interface explicitly, it creates its own update function that we can use. Get rid of this. So everything on your right here updates in the game. If we use ICMP initializable, so on activate, so methods called on startup. So when the actual object that has this component, has the example component on, when it becomes activated at the start, anything you type in here will get called, and at the end you will get called. Anything you type here will get called once. So once the game object is deactivated, it will get called here. If you want to handle collisions or the rigid bodies that we talked about earlier, we call upon ICMP collision listener. And this is pretty self-explanatory as well. So on collision begin, it happens when the collision starts. So it happens one time when this object that holds the collider so it makes contact with another object, and once the collision has finished, anything that's written on collision end gets called. And while colliding, anything that's written on collision solve will get called. So this is example is if you want to get a normal of the collision, or like the perpendicular angle of when you make contact with another object, it'd be a good idea to call it on collision solve. And other objects such as, let's see, any sort of collision data, so you can get the normal, the position, the tangent, all this stuff. Any sort of collision data that you want, you need to call out on collision solve. So I'll write a simple script to give you an idea of how the scripting works here. Actually, let's use this one instead. So use this game object, and we want to get its transform and we want to move it, so we just type in move by. Move it up, so up would be vector 2, and in duality up is minus value, so unit y minus times time dot delta time, so that it runs at the same speed on all machines, times let's use 10f. So if I attach this example on a game object, the object should move up by this value here. Let's save it, go to here and rebuild. Okay. Go to this blob here, add component. Let's use example. Now if you play it, it should go up. It's going up very, very slowly, as you can see here. So that's the duality in a nutshell. Hope you found this sort of introductory to duality useful. In the next sort of episode, I'll be showing you how I made a breakout clone. This is a breakout clone that I made using the concepts of this video. In the next video, I'll be showing you how I made this plus more step by step. Also follow my journey on making a ninja roguelike game using the Duality game engine here. I'm planning to make more short games covering different features of Duality, so if you like the sound of that, hit that like and subscribe button and the bell to be notified too of when my videos come up. I've been Mar Allen, you've been awesome, stay awesome, take care, and I'll see you soon.